Hello YouTube and welcome to Heathen Hacks. During my Corsair Lighting Node Pro unboxing, setup, and review video, click right here to check it out by the way, I briefly compared the LNPro and Phanteks Neon RGB strip combo set and said that I would get one in the future. Now that we're in the present, which was that past's future, we're going to unbox it and talk about its pros and cons. I would also show you the steps that I had to do just to make it work because of some complications on the LNPro strip. And since all of my newer videos have timestamps now, you can just skip the LNPro surgery part and head straight for the review if you want. Let's go! Okay, here's what the packaging looks like. Phanteks Neon Combo Set. Digital RGB LED strips. As you can see here, it only has one strip instead of two because the other strip is already attached inside the case. Here's what the LED strip looks like up close. Other things inside the package is this digital RGB motherboard adapter. It looks like this. You can connect this to one of your motherboard's 5V or AaAaARRrGB LED header to control it using your motherboard's LED software if it has one. On the other hand, you can also use it as an extension cable for daisy chaining RGB LED strips if you wanted to, because it has an RGB LED connector for input as well. This right here is where you connect the input side of the LED strip. There's also another extension cable provided, which I can't show you anymore because as I have said earlier, it's already installed, but it basically just looks like this adapter, just without the connector for the motherboard. Also in the package are 14 pieces of double-sided tape for attaching the mounting plates to the surface of the case, and 4 pieces of 90 and 180 degree mounting plates and 6 pieces of the flat ones. Now, if you're going to be using your motherboard to power and control the Phanteks Neon RGB LED strip, the setup of it is really easy. You just have to locate your motherboard's RGB headers, connect the LED strips, and you're good to go. I mean, provided that it's on the list of compatible softwares. But if you're going to control it using other RGB LED software like iCUE for Corsair for example, you need to connect it to one of their LED controllers for you to be able to control it. In my case, I'm going to use my Lighting Node Pro. The only problem is that I don't have a spare LED header on it since both are being used by the two sets of LED strips. One is connected to two LED strips inside the case plus the LED strips on my DIY iCUE controlled bias lighting which are attached to my two monitors. Click right here to check it out. The other set of two LED strips are connected to the other header. My plan is to connect the Phanteks LED strip to the second set of LNPro strips. But in order to make it work, I'd have to do some surgery first. So my plan is to connect the Phanteks LED strip to the second set of LNPro strips. But in order to make it work, I'd have to do some surgery first. Because, unbeknownst to me, apparently the LED chip right at the output side of the LED strip where I'm planning to connect the Phanteks strip is broken already. For demonstration and to better explain what's happening, I have hooked it up to an Arduino Nano. As you can see here, the LED near the output connector is not lighting up at all even if I have set the code to light up 11 LEDs. Here's a closer look. I think I just need to remove the bad LED first and then solder some wires from an LED header or connector onto its data pins and power. And then connect the Phanteks strip to it and iCUE would recognize it as an additional Lighting Node Pro LED strip. But first, we need to do some tests. And in order for us to do that, we need to remove the protective silicone coating. So I just removed the protective silicone coating. Hold on, let me just turn this to manual focus. There we go. I removed it using a Stanley knife or a box cutter and a flushed wire clipper. Now, to determine which pin is which, let's go ahead and do some continuity tests. According to this label, the 5V pin is on the left side. Data out or signal out pin is at the center. And the ground pin is on the left. Let's start with the 5V connection. There it is. Data out pin is right here, and this is the ground. So this is the 5V connection, data out, and ground. That means the pin that is left is the data in. Data in should be connected to the data out of this LED chip. But there is no connection. Well, I was wrong. Apparently there is. Now I'm confused. There is connection between the data in of the last LED chip and the other one. But the last LED chip is not lighting up at all. Let's see. I wonder if it's really broken. Let's try powering it up using the Arduino Nano just to check. Data in, ground, and 5 volts. What? Apparently I was wrong again. This chip is not broken at all. Now we know that no LED chips are broken, so my best guess is that the fault is located somewhere in the flexible PCB. That's just a guess though. However, according to some more continuity tests that I did, it's not like that at all. See, right here I have probed the 5 volts, data out and ground pins of the second LED chips and then connected the other probe to the output connector and no signal was lost. I don't know what's wrong with it honestly. For some more additional tests, I have soldered the jumper cable to the data in of the second LED chip and connected the power to the 5 volts and ground of the last LED. If everything goes well, this test LED should light up in sync with the second one. Let's plug it in. There we go. Let's try and connect the jumper wire to the data out pin and see what will happen. Well, let's do a continuity test first. Data out from the second LED to the data in of the first one is good. Data out from the second LED to the data in of the test LED is also good. Normally, the test LED should light up after the second LED, but it's not. Now, let's try and solder the jumper wire of the test LED to the data out of the third LED chip. There. See? What's happening now is both the test LED and the second LED chips are lighting up in sync, because they are both connected to the same data out pin, the data out pin from the third LED I mean. Just like when we soldered the test LED to the data in of the second one. Alright, right here I have changed the connector for the test LED with the male counterpart of it and hooked up the Phanteks LED strip. What should happen is that 3 out of the 28 LED chips on the Phanteks strip should light up. Because I have removed the last 2 LEDs on the LNPro strip and diverted the signal to this one by replacing the second LED chip with an LED connector that is connected to the Phanteks strip. Why 3? Because as I have mentioned earlier, I made a code where 11 LEDs should light up one after the other, and the only LEDs present on the LNPro strip are 8. So the remaining 3 LEDs that should be lit up are transferred to the Phanteks strip. Let's change the code again and make it light up 36 LEDs. 8 LEDs on the LNPro strip and 28 LEDs on the Phanteks one. Upload the code, and there we have it. Let me just turn the lights off to see it better. Let's try some other effects. Let's try Cylon. Just going to lower the ISO again since my camera can pick up the colors correctly. And there we have it. Now, this is the first LED strip that is connected to the second header of the LNPro. And this is where we would connect the LNPro strip that we performed some surgery on. So, we would connect this here. And the output side, the side where we use the second LED chip solder pads as the source of both power and signal, onto this one right here. This is the extension cable that I was talking about earlier as well. It's connected to this Phanteks strip and is already neatly tucked in at the back of the case. Before we connect things up though, let's make the output end of the LNPro strip that we performed some surgery on look a bit nicer. By using the power of editing, here it is, already done. Used a few heat shrink tubes with varying sizes and some super glue to secure it or hold the protective silicone coating in place. I have also added the magnet. See? Now, I'm just going to keep the connector like this because it's not going to be seen anyway. Let's plug this one here, attach it to the case by using the magnets, and then this one should be plugged into the extension cable which is connected to the Phanteks strip. There we go! It's lighting up now. Well, apparently one LED chip on my RAM is dead already. For a quick demo, I have disconnected the main Phanteks strip, the one that's already installed, and connected the other one because the GPU and the cables for the 24-pin connector of the motherboard is blocking it a little. Let's zoom in a bit. Now here are my custom IQ profiles and how they look like on the Phanteks strip. While it's showing up in the background, let's go with a review as well. The Phanteks neon RGB LED strip looks really good, especially when installed correctly. It has good color reproduction and it's easy to add to your builds because of its motherboard RGB LED header adapter that is already included. Not sure about this, but my guess is it's also using WS2812B LED chips for better compatibility with other LED strips as well. I mean, as you can see here, IQ is not officially on the supported RGB controllers or software on the packaging, but I can control it just fine. Although I just connected it to the LNPro strip to control it, but still. You also have two options when it comes to orientation. You can install it vertically or horizontally. However, even if the orientation option is more than 100% more than the conventional RGB LED strip, it can also be one of its downfalls. For example, you can only use the vertical orientation for straight and horizontal 90-degree turns, and the horizontal or lying down orientation for the straight and vertical 90-degree turns.
I know, it's a bit confusing. So here are some visual examples of what I said.
On the vertical orientation, the LED strip can only go straight and do a horizontal 90-degree turn or bend like this. And on the horizontal orientation, it can only go straight and do a vertical 90-degree turn or bend like this. It can't unfortunately do both at the same time. And yes, I do play Minecraft now, from one time consuming game to another. Good luck me! Another one of its downsides is the provided double-sided tape, which came off just a few days after installing it. So I'd recommend using an outdoor rated 3M double-sided tape like this instead of the provided ones. In my opinion, besides its downsides, it does really look good. I might be a bit biased though because I really like it. At the end of the day, it's just another LED strip, but this one is quite different. As always, thanks for watching and see you again next week. Maybe.